Hi there. Welcome to this demo on container security using ImageStream on Openshift. My name is Sumit Mukherjee. I'm a specialist solution architect at Red Hat. And today we are going to explore how Openshift enhances container security through image streams. In the container world, images are tagged for human-friendly version control by the container runtime. These tags are essentially names that we can easily refer to, but there's also a more precise identifier called a digest. The digest is a unique long string that ensures we are using the exact version of the container image. The problem with tags, while tags are convenient, they can sometimes lead to confusion. Docker and Podman, for example, make it optional to mention the tag when referring to an image. If no tag is provided, the runtime assumes that the tag is latest. This can make it easy to overlook or pay less attention to the image version. Now, another problem is tags can be updated without your knowledge, right? So even if you are diligent about specifying tags, there's a catch. Tags can be updated to point to a newer version of the image without you realizing it. So if you've been using a specific tag for your builds, believing it's the same version, you might be mistaken. So let's demonstrate this issue on Kubernetes. So I am using a Kubernetes playground. So let's go ahead and look at a simple Java code. It's a Spring Boot code, and it exposes an API. So let's go ahead and build this out. So now let's run it. Okay, so it's running. So let's go ahead and test it out. So I'm going to, and that's it. This is a very simple application. It just demonstrates it gives just my username and password. So let's now go ahead and build an image out of it. So I have a Docker file already here. So it's just going to create a Docker file out of it. So let's go ahead and uh, build the image, podman build -t. I'm going to upload it on uh, Quay or Key, sometimes said. It's a container, open source container registry. So it is built. Go ahead and try this out. So I'll say podman run rm d p 8080 and the image name. We'll just quickly copy this and paste it. I think something might be running. Yes, I have left my code running in the background. So let me just quickly kill it. Right. And let's try it again. All right, so it is running. So let's go ahead and check. Yes, it is running. And let's go ahead and do that same exercise again. And it is same, right? So let's go ahead and push this image. So podman push. So what it is doing now is it is pushing this image to a repository that I have created in an open source container registry called Quay.io or key.io. It basically is here. So let's give it a few minutes and few seconds rather, it should be up. All right, so let's go ahead. It's up now. Let's go ahead and refresh it. All right, so we have this tag, and this is the digest that we were talking about. Okay. So fine. So now we have our application on a container registry. So now let's go ahead and create a deployment. So let's say I will create a deployment of YAML. So this is, I'm using a Kubernetes playground. So I'll just copy paste some, right. So yeah, deployment name is ImageStream demo, replicas one, match labels and container. And this is where I am giving the image descriptor, right? And container port 8080 because that's where it is exposing. So now let's apply this. And it is created. Let's wait for it to come up. Sorry, I'm sorry. XCTL get pods -w. So it's in container creating. Just give it a few seconds and it should be up. All right, it's up now. Now we need to expose this in order to access it. So we'll do kubectl. First, let's get the deployment name. So kubectl get deployment, right? And kubectl expose deployment and the name of the deployment. All right, so let's go ahead and check kubectl get svc. Okay, we have this. And let's go ahead and do a curl http /API/users. So here we have, just for good measure, JQ. So I am getting the response. All right. Now let's see the problem. So let's say I have a malicious intent and I go ahead and let's say modify the code. So here I'm simulating the malicious modification, or maybe not only malicious, might be accidental updation also. Is saying hackyou.com, right? Let's go ahead and save it and let's build it. Okay, so it's built. Now let's go ahead and create an image out of it. And podman build again. And let's push it. So the interesting thing here is that I pushed it against the same tag. Okay. So while my code has changed, but the tag remains the same. So now let's go ahead and verify. So here, if I go ahead and update it, so it says few seconds ago, let's go ahead and look at history. And as you can see, it has changed. It was created pointing to this and it has moved to this. Okay. So the digest has changed, but the tag remains the same. So now let's see what's the problem. So here, now we have this one running. So let's go ahead and scale this. Scale minus replicas, sorry, replicas is equal to 2. And deployment, and the name of the deployment was this. Okay, so let's check it out. kubectl get pods -w. Let's wait for both of them to be running. So what's now going to happen is, now as I keep calling this service again and again, it's going to load balance between these two pods. And you are going to see, interestingly, once when it goes to the older pod, it will serve this name as Sumit and email as sumit@redhat.com. And when it points or switches to the other pod, which is the newer version, and which will take from the latest version image, right, from the container registry, it's going to say as name as hacker and email as hacker@hackyou.com. And now we have both of them running. So let's go ahead and get the service. And let's copy this and do a curl http /API/users and GQ. So as you can see, it is alternating between hacker and Sumit, but you can see that there is difference, right? So this is the problem. You had a deployment, you scaled it up, but unfortunately, since the image had gotten updated while the time you scaled it up, you are inadvertently using a wrong image version. Okay, so this can cause a problem. It might leave you in splits wondering what has gone wrong, especially if you are not controlling the image. So as you can see, the latest stack can point to different versions of the image over time, right, which poses a security risk and can lead to inconsistent deployments as well. So now let's introducing OpenShift ImageStream. So let's see how OpenShift addresses this problem with something called an ImageStream. So what is an image stream? An image stream and its associated tags provide an abstraction for referencing container images from within OpenShift container platform. The image stream and its tags allow you to see what images are available and ensure that you are using the specific image you need, even if the image is in the repository changes. Image streams do not contain actual image data, but present a single virtual view of related images similar to an image repository. You can configure builds and deployments to watch an image stream for notifications when new images are added and react by performing a build or deployment respectively. So what are the benefits of using image stream? Now, ImageStream offers several benefits, primarily version control, ensures consistent image versions across deployments. Security helps in maintaining security by avoiding unexpected image updates. And automation, it simplifies automation in CI/CD pipelines, as we talked about triggering builds based on image stream changes. You can read more about image streams from OpenShift documentation. Okay, it has a lot of other benefits. So now we come to the part of using demo or using image streams on OpenShift. Okay, so I'll show you how to use image streams on OpenShift. All right, I'm using the OpenShift sandbox. Okay, so what we are going to do is we're going to do the same thing. We're going to do a deployment on OpenShift using the image that we did. But before that, since I want to show the consistency, so let's go ahead and change back the image. So let's go ahead and make it Sumit. Sorry. And save it. And let's go ahead and build it again. Let's build it. The bit image again. There it is. Let's push it. All right, so it is updated. So let's go ahead and verify. Let's go to key and let's go up, refresh it once. And here we go. It has again changed, right? So hopefully it has gone to the correct state. So let's go ahead and create a deployment. So OpenShift has a very easy way of creating a deployment. We're going to, instead of writing a deployment.yaml, what we're going to do is we're going to create add and we could take this container image because we know the image and let's take this is the image address. So let's go ahead and copy this and put it here. Let's say latest. So it's validated and let's go ahead and select our no application group. This is the name, the source type. We don't want to do serverless. We want to do deployment. And it's the target port 8080 and we'll create a route. So that's going to expose our application as well. So let's go ahead and create it. So this is the deployment that it has created. Let's continue creating. Let's go and view the logs. And yep, it has started. Let's go ahead and quickly go back to the topology. We are going to access the application via the exposed routes. So this is a route. Let's go ahead and copy it and paste it here. And we say API users. And here we are. Okay, we get the original information. So now it's fine. So what we are going to do is in the background, we are going to again change it back to hacker. So this is basically simulating a change in your code. Okay, let's go ahead and build it quickly. And let's build an image out of it. I'm keeping the same tag as the latest, and let's push it. Okay, so it has been updated. And now for the finale, we're going to go into Kubernetes OpenShift. And now we have one pod. And just like we scaled the Kubernetes deployment, we're going to scale it by clicking on it. Two. So now we have two pods running. Let's go ahead and confirm that they are individual. Yes, they are running. So let me just increase the size. All right, let's go ahead and now you can see I am actually hitting the service again and again. In case it's not visible, let me go ahead and do a curl of it. Curl and JQ. So as you can see, it's not changing. The reason it's not changing is that because OpenShift has done its magic. Although the actual image in the repository in the container registry has changed, you are not referring to this container registry image directly. And this is where the magic of ImageStream happens. So when we created this deployment, what OpenShift did for us in the background is it created an image stream here. Okay. And if you click on it, it's going to show that this created an image string. This is the latest tag. This is an image stream tag, nothing to do with your container registry tag. Okay, so this is the image stream tag, and it has taken this image from this repository. However, this is the identifier. Okay, so essentially what it says is it is referring to this digest. Now let's go back into the key. And if we go and look at tag history, okay, this is the one. Okay, this is the one where we changed it back to submit, right? So let me go ahead and look it up. It says 48050, right? So if we go and check it here, yeah, it's 48050. So with image streams, you can see how OpenShift helps maintain consistent and secure deployments by managing the image versions more effectively using the digest instead of the tags at your image registry. So in conclusion, while tags in Docker and Kubernetes can lead to potential security and consistency issues, OpenShift's image streams provide a robust solution for managing container images. Thanks for watching.